Hello friends, today in this video we are going to study about condition for parallelism and perpendicularity of lines in terms of slopes. So friends, let's start. See, first, conditions for parallelism of lines in terms of the slopes. Here you see two lines L1 and L2. The angle of inclination of the line L1 is alpha and inclination of line L2 is beta, and if L1 is parallel to L2, then their inclination are equal. Why they are equal? Because this angle is corresponds to this angle. So the corresponding angles are equal when two lines are parallel. So here L1 is parallel to L2. That's why alpha is equal to beta, because they are corresponding angles. Understood? So now you can write tan alpha is equal to tan beta, because inclination varies from 0 degree to 180 degree. Beta also varies from 0 degree to 180 degree. And as they are equal, alpha and beta are equal to each other. So the tan alpha is equal to tan beta. Okay? And you know that tan alpha is nothing but slope of line L1, and tan beta is the slope of line L2. So here M1 and M2 are the slopes of line L1 and L2 respectively. So you can write tan alpha is equal to M1 and tan beta is equal to M2. So what you get? Now if L1 is parallel to L2, then their inclinations are equal and their slopes are equal to each other. Okay? Conversely, also we can prove if slopes of two lines are equal, then they are parallel. So here you see, if M1 is equal to M2, then we can write M1, tan alpha, M2 tan beta, slope of the line L1 and L2. And you can write here alpha is equal to beta, because both alpha and beta lies between 0 degree and 180 degree. So you can write alpha is equal to beta, and as alpha and beta are corresponding angles and they are equal, so you can write L1 is parallel to L2. Okay, hence what you got? If slope of two lines are equal, then two lines are parallel to each other. So, in conclusion, we can say two non-vertical lines L1 and L2 are parallel if and only if their slopes are equal. Okay, here non-vertical line L1 and L2. You know vertical line, slope of vertical line is not defined. So, the line must be non-vertical lines. So, here two non-vertical line L1 and L2 are parallel if and only if their slopes are equal. That means if two lines are parallel, then their slopes are equal. If their slopes are equal, then lines are parallel to each other. Okay, next. Conditions for perpendicularity of lines in terms of the slopes. Here you see L1 is perpendicular to line L2. Okay, so if the line L1 and L2 are perpendicular, then we have beta is equal to 90 degree plus alpha. Here you see in this triangle, right angle triangle, this angle beta angle is exterior angle. So you know that the exterior angle is equal to the sum of opposite interior angle. So alpha plus this 90 degree. So beta is equal to alpha plus 90 degree. Okay, you can write here beta is equal to 90 degree plus alpha. Okay, now you take 10 both side, then 10 beta is equal to 10 90 degree plus alpha. Here beta and 90 degree plus alpha lies between 0 degree and 180 degree. So you can write 10 beta is equal to 10 90 degree plus alpha. Here 10 beta is equal to the formula, you know, this is equal to what? Minus cot alpha. So you can write minus cot alpha. Here 10 beta is equal to minus 1 by 10 alpha. Why? As you know, cot alpha is reciprocal to 10 alpha. So you can write cot alpha is equal to 1 by 10 alpha. So here minus 1 by 10 alpha. Now you take this to left side, then 10 alpha into 10 beta is equal to minus 1, and here 10 beta, here 10 alpha, okay, is equal to minus 1, and 10 alpha, what? Now slope of L1. So 10 alpha is equal to M1 and 10 beta is equal to M2. Okay, so you can write M1, M2 is equal to minus 1, where M1 and M2 are the slopes of L1 and L2 respectively. Okay. Here what we prove? Now if L1 is perpendicular to L2, then we have what? The product of the slopes of two lines is equal to -1. Now we shall prove. Conversely, if m1 into m2 is equal to -1 given, then now we shall prove L1 is perpendicular to L2. L1 is perpendicular to L2. L1 and L2 are perpendicular to each other. Here m1 into m2 is equal to -1 given. Here m1 is what? Tan alpha. Tan, tangent of the angle of inclination, that is tan alpha, into tan beta. M2 is what? The slope of L2, that is equal to tangent of the angle of inclination, that is beta. So here tan beta is equal to -1. Now you take tan alpha right side, then tan beta is equal to -1 by tan beta. Sorry, tan alpha. Tan beta is equal to -1 by tan alpha. Then tan beta is equal to, you can write this as minus cot alpha. As you know, tan alpha is reciprocal to cot alpha. So you can write here this, okay, and cot alpha is equal to 1 by tan alpha. So you can write minus what? Cot alpha. Here tan beta is equal to, you can write this, because tan 90 degree plus theta is equal to minus cot theta. So you can write here tan alpha plus 90 degree. Here angle is alpha, so you can write tan alpha plus 90 degree. As beta and alpha plus 90 degree lies between 0 degree and 180 degree, so you can write beta is equal to alpha plus 90 degree. So here beta is equal to alpha plus 90 degree, and you can transposing alpha to left side, then you get beta minus alpha is equal to 90 degree. That means beta and alpha differ by 90 degree. Okay, so L1 and L2 are perpendicular to each other. Okay, perpendicular to each other. Hence, in conclusion, we can write two non-vertical lines are perpendicular to each other if and only if their slopes are negative reciprocals of each other. If two lines are perpendicular to each other, then their slopes are negative reciprocal of each other. Here m2 is equal to minus of 1 by m1, or you may write m1 into m2 is equal to minus 1. Okay, if m1 into m2 is equal to minus 1, then we can write L1 perpendicular to L2. Okay, L1 and L2 are perpendicular to each other. Okay, next, see two example. Example here, question number 4. Here the line L1 makes an angle 30 degree with positive direction of x-axis. Then the line L2 is parallel to the line L1. Find the slope of the line L2. Here two things are given. One is the line L1, the angle of inclination of line L1 is 30 degree with positive x-axis, and L1 is parallel to L2. Two things given. So you have to find the slope of L2, and you know that as they are parallel, L1 is parallel to L2, so slope of L1 is equal to slope of L2. You know from the condition for parallelism. So you can write here slope of L1 is equal to m1, that is equal to tan 30 degree, and tan 30 degree is equal to 1 by root 3. And as L1 is parallel to L2, so their slopes are also equal. So you can write m1 is equal to m2 is equal to 1 by root 3, where the slope of L2 is equal to m2. Now come to second question. The line L1 makes an angle 30 degree with the positive direction of x-axis. Here L1 makes an angle 30 degree with positive direction of x-axis. Okay, then the line L2 is perpendicular to the line L1. L2 is perpendicular to the line L1. Find the slope of the line L2. Now we have to find the slope of line L2, that is m2. We have to find m2. So let the slope of L1 is m1, that is equal to tan 30 degree. Here angle of inclination is 30 degrees, so slope of L1 is equal to 1 by root 3. Tan 30 degree is equal to 1 by root 3, so slope of L1 is equal to 1 by root 3. And let slope of L2 is equal to m2, and as you know L1 and L2 are perpendicular to each other, then you can write m1 into m2 is equal to minus 1. Okay, and m1 we have 1 by root 3, so you can write 1 by root 3 is equal to minus, here 1 by root 3 into m2 is equal to minus 1, and m2 is equal to, you take root 3 right side, then you get m2 is equal to minus root 3. Okay, so slope of m2 is equal to minus root 3. As it is negative, so angle of inclination of the line L2 is an obtuse angle. Okay, thank you students for watching this video.